Hi, welcome back to the part 2 of the Bionic Hybrid X210 building instructions. I'll just give you a little reminder here, as in the step 1 video, all the parts can be downloaded from the Thingiverse site, and you're just searching for the Bionic Hybrid X210 FPV racing drone. In this video we're going to look at printing all the 3D parts, including the settings I've used on the 3D printer. Obviously, to print parts like this, you're going to need really good settings, otherwise they'll fall over. So let's look at a few of those settings here. Now, I don't think it's worth me reading out all the settings here. I'll just highlight the ones on the screen that are important, or at least I think are important, such as the nozzle size. Here the retraction distance will be really down to your own printer and your own filaments that you're using, but these are just an example of what I've been using. I've printed all the parts at a 0.2mm layer and set all these here to 5 just to make sure that the end result is quite strong and sturdy. It's important here, I think, to set up the first layer height and speeds, but again it's a bit printer specific really, so I'll leave it up to you. The skirt, though, I do believe, especially when printing ABS, is necessary, and I always like to put 2 layers and 20 outlines around the part. This keeps the bed warm. I notice that I start off with 0.8mm from the part for this skirt, but in all fairness, depending on your success rate, you may want to reduce that maybe to 0.6. So just reduce it in here, this here, and it will just bring it closer together and make the skirt stick to the part, and just help to keep that upright part, because it is very thin. Here we're looking at the infill, and I'm using 50%, although to be fair, for the extra strength and the cost of the extra filament, it might be worth there including a strengthening layer every 1 layer to make it solid. Looking at the support, it's important to set it from base only. There are some areas that really do not want any support material inside. I'm using the support of 23%. Again, it's a little bit printer specific, but I found that at this percentage it's very easy to clean the parts off. If you put it too high, you're going to really struggle to get all your support material out the little holes in the model. Moving on to temperatures, well, I have the bed temperature set at 95 degrees. Now I am using the print bite surface, so that is relevant here, and so we are talking printer specific again. Printing my first layer at 240 and then moving on at 235 for the filament. Remember, I'm printing ABS. If you're moving on to PLA or PETG, these are all going to be different. Cooling, of course, printing with ABS is 0 cooling. Make sure that's turned off completely. A few little parameters here, G-code settings. Scripting, well, this has got, I have a toothbrush head that cleans my nozzle before it starts printing, so that's just really on that. You can have whatever you've got. And just a few other settings here. Print speed is 60mm per second, but again, you might gonna have something different for whatever material you're gonna print. Again, I like underspeed, especially for the outlinings. It gives it extra strength and just makes the part look a little bit neater in the end. So if we just take a quick look at what these settings will do with the part, we can analyse this in Simplify 3D. And we can see with this part there is no infill. With the settings we have and the outline, outer perimeters and things, we can see that there's no infill on that part, so you get a nice solid structural part. Let's remove that and put in something a little bit where we will have infill, like the base. Okay, let's generate that part and have a look. So what we see here is that we have got some infill here noted by the orange, and here we've got the support material noted by the grey. Let's just have a better look at that, and obviously lots of infill there in the middle section, and the support material there in grey. So this is going to be quite easy to remove. As you can see, there's only 4 lines of infill, of support in the main area there. So that should be pretty easy to remove. So assuming you've got all your settings in your 3D printing slicing software, then you should be able to print really all the parts with ease. All the parts really come with one flat side, so they can be easily laid on the bed. These are probably the most difficult ones to print, the standoffs, but as you can see, it is entirely possible. Just make sure you get your settings correct and use that skirt attached to the bottom to make sure they stay up in the right way. I did mention that I was using the Print Bite surface. It's a special surface, it's really good for ABS. Can't really say much about anything else, but as you can see here, that when it's finished and cooled down, you literally just slide the ABS off the surface. It really is as simple as that, which is why I use it. I used to use ABS juice and all sorts of things, but not no more. That's been on there for hundreds of prints, and it's really exceptional. And here's all the finished laid out parts. And again, if we just walk through the parts one by one, you can see here where we've got the support material, which we need to clean out of the part before we use it. And then we need to drill out these areas here. I just use like a little hand drill for these. It's a 3mm drill bit. Just put them through there, just to clean it up, just make the bolts go through a little bit easier. And again, same on this part here. This is the top part. We need to clean out these little holes here. And note these tubes. These are the tubes for the RX antennas. So they should be hollow. If you've got your support material set correctly in your 3D printer, then they will be hollow all the way through. Worth checking at this stage that that's actually the case. This is the base, but the top part of the base, if that makes sense, we'll see that in a little bit. This is a bit that holds the arms to the base. Again, we need to just drill these out. There's no support material on this, so it's just a case of drilling those out. Just mention there that these need drilling out as well as clearing. These are the camera supports, so there's nothing really to clean there. Although we will be doing some filing later, just to make sure that those little tabs sit inside the base and the top part. And you see the structural part of the side, so that should go on the outside of the model once it's done. So that's going to go in there like this, up that way, that's it. So it goes on the outside, so that extra ribbing goes on the outside. This is the RX base and your 3-in-1 lost model alarm. Again, there's a little bit of support material to clean out there, and we're going to file them tabs off just so they fit into the base snugly. 2 bolts will hold that down though in the end to keep it actually in place. So there, just a quick demonstration of what we're going to need to do to file those parts off with the little needle file. This is the flight controller mount. This again needs cleaning out with some support material and taking the drill through, obviously. Essentially, on top of this will be the power distribution board, which will then be screwed down using these little nylon hex standoffs, and then on top of that will go your flight controller board. So it looks something. It's going to look something like that. Obviously, we're going to stack it up as we build these. So that's the power distribution board that will fit on top. Next, we've got the 3D printed standoffs that are printed with the larger circle on the floor, printing in a vertical method up off the print base, with the chamfered top going into the top of the model. Next we've got the RX side mount, which fits onto the base, onto the RX base. Notice that there's an arrow there pointing upwards, and notice where that corner is, and it needs to be pointing forwards, otherwise the top won't fit on correctly. Then moving on to the carbon fibre arms. These are 4mm thick, and they're part of the ZMR X210 from FPV model, and they should fit in to the base like this. These are very strong arms, by the way, and I've yet to break one of these arms, and so I wouldn't bother ordering spares. And it clamps in like this, giving a very solid and rigid structure. Like I say, they've done lots of testing with this model, and it really is quite strong. So moving on to how we clean all the parts up to get them ready for use. As you can see there, the support material, I just use a really small screwdriver here and just dig that support material out. If you've got your settings right, it should come away quite easily. As you can see, I'm just pulling on that and it's almost out. There you go, and it's out. I'm just going to clean up that hole. To be fair, I'm not really sure it's necessary, but I like to just finish the hole off so it's nice and smooth. And take a 3mm drill bit through the hole just to make the putting of the model together more easily. We are going to use a 3mm nylon lock nut at the bottom there, so there's no need for it to actually be screwed into the plastic itself. The idea, of course, of that surrounding is to be able to get your 3mm nut driver, I guess it's called, inside that hole, so you can tighten up the nut correctly. And again, just finishing off the hole so it's really nice and clean. You should really be enjoying this part of the build. It is part of the build. Don't feel it should be rushed. It's the time you take now will pay dividends later. Next, moving on to the camera mount and the base topper, if you like. And that needs to go into there, so we need to clear these little tabs up. Now I use a little needle file just to take off the edge, any printing issues, both sides. Of course, if you're using ABS juice, then you need to take a little bit more off, because the actual ABS juice adds like an extra little bit of a layer. But I'm not doing that, so I can just take a little bit off here. I'm leaving you the whole video here so you can see how long it takes to actually clean up, so you know how much you need to be taken off. So it's not that much. You're just really just tidying up the joint a little bit on all the edges. What you don't want this to be is too loose. If you get this part too loose, then what you'll actually end up doing is causing vibrations through into the camera, and cameras and the video really doesn't like vibration. So you should be able to push that in, not forced in as such. It should fit, but you know, not too weak either. You may want to take a little small hammer just to finish that in. So what I would do is I'd just use a little hammer like this, and I'd just tap that into the section. But of course, first of all, I need to clean off the top part as well, the top tabs. Again, I'm leaving this bit in the video literally just so you can see how long it takes. I mean, sometimes cleaning up the parts of 3D printed can be a little bit time consuming, but it's worthwhile, because as you can start to build the model up, just having this little bit of pre clean up before you start building, it just makes the model go together quicker once you actually start. So it's certainly worth the time. So remembering that the ribs on the on that camera holder there go on the outside. You'll see what I mean by the ribs as you build them, but there's on the edges of that there's like sort of strengthened ribs. That seems to fit in there okay. So I'd put that in there. Then obviously I'd normally put both sides in, but just so you can see that, don't feel there's anything wrong with giving it a little bit of a tap with the hammer. Obviously not too hard, but it should just hold together like that. Of course the bolts will hold it all together in the end, but this is just to make sure that that's nice and tight, and again so it doesn't cause vibrations through into the camera, which you will see through into your goggles and ruin the whole FPV experience. So moving on to the standoffs, these do take a little bit of time if I'm honest. As you can see, they don't fit first time. You usually have to do a little bit of filing here to get these right. Now what you're after here is not such a tight fit. I mean they want to be snug but not too tight. So we're just going to file the edge off, as with all 3D printing things. You'll probably end up with a little lip on there, so I'm just trying to use like a sort of, I don't know, 20 degree, 30 degree angle on the end just to get rid of the lip at first. And again, I shall leave this bit in to the video so you can see how we want to get these to fit. So I'm using this needle file again across the edge, just for the thickness that it's got to go into. Just taking a little bit off. My printer, for some reason, started leaving some little knurls on down two sides as the head jumps from one to the other. These are a little bit annoying, but I guess it does come in handy in a minute, as you'll see when I need to grip them with the mole grip so they don't spin. And there you go. So that looks about right, really. That's in there. It's not too tight. Take a little bit more off, just to finish it off, especially around them knurls that I seem to have on my printer. You might find yours are nice and round, which would be great for you. Gotta tell you, my fingers are starting to hurt now, so there you go. Look, that's perfect. So it's in there. You see, I had to waddle it out a little bit, but not. So it's not dropping out, but it just pulls out quite easily too, and that's perfect. And this side will need to be done now. You have to be careful with this side now. It's not meant to be structurally solid without the bolt through, so just be a little bit careful. You're not going to break it by filing it, to be fair, but you could break it if you pushed it into its hole and then sort of bent it outwards rather than pulling it out or twisting it outwards. So just bear that in mind as you're doing this part. Again, you want it to be in the hole, snug fit, not falling out, but not tight either. So there you go. Look, it's gone nice and in, and I can pull it out. So when together, as you can see, the two bits are going to go together like this. Next, we need to take a 3mm drill bit through the centre of that, so the 45mm bolts go through. Now, do not take it through the small end if you like, because you risk damaging it. Take it through the larger side. And I'm using an electric drill here because it's a little bit more difficult, and just gripping them not too heavily with the mole grips, but just having a nice tight purchase on the part, and take the drill through a few times until the bolt can fit straight through the middle with ease. So in the end, it should be like that. So I think that's it then for the second part of this video sequence of building the Bionic Hybrid X210, and just leaving you there with a screenshot of the speed results that we got. 70 miles per hour. It's pretty awesome when you're flying FPV. So in the next video we're going to be looking at the electronic hardware. We're going to be looking at how we put a little bit of water repellent on there using Corrosion X, and then really just getting ready to start putting it together. So I'll join you in the next video, hopefully. Well, it's bank holiday weekend, so hopefully this weekend. Don't forget that if you've enjoyed this series, don't forget to look at my YouTube channel and like and subscribe. and then you'll get notifications if you switch them on of when I upload the next video. Thank you for watching.